Here is the solution to lab number 3. Continue on where we left off. We're finding the slope of the altitude from A. And the altitude has to be perpendicular to BC. So once again, we need to calculate the slope of BC and take the opposite reciprocal of that. So I'm going to right-click, insert a line, and this time we'll find the slope of BC. And this is similar as to before. We'll take the rise. Divided by the run. Okay, and then the slope that we need is going to be the opposite reciprocal, which is equals -1 divided by this. And now we need a point for this perpendicular bisector to go through. Well, if you remember, the easiest point is just going to be to use A. We know that the altitude, did I say perpendicular bisector? I meant altitude. The altitude does go through A. So in this case, this is easy enough. We just take the x value from A. That's our x sub 1. And the y value from A, which is y sub 1. Okay, and the last step is to find the median from vertex A. The median goes from A to the midpoint of BC. So now we need the midpoint formula again. And let's do that bit first. The midpoint is the average of the x values of B and C. Average is halfway. And let's do this one is the average of these. So let's check if it's right. 1.5, that seems right. 0, that seems right. So we know that it's going to go from A through this point, but now we need to calculate the slope based on these 2 points, not based on the rest of the vertices. So this we can use the same slope formula, the change in y. In this case, we'll go from A, and we'll use this y value, the 0. So that's a change in y divided by the change in x. This x coordinate minus, and we'll use the 1.5. So this has a slope of 6, and that does look very steep. It does rise 3 and run a half, which is 6. So just checking to make sure. So we have these things. I didn't even need the extra room, I guess. So those are the parameters for the point slope equation of the altitude, of the median, from vertex A.